Here we go. We're on type 5. Type 5 is when you are given a table and probably Riemann sums question possibly or separate. So I'm going to show you a couple table questions in our examples today. First of all, a couple of tips you need to know about these types of problems. Tables generally are used to test a variety of topics. You could analyze a function, increasing, decreasing, max, mins, all that kind of stuff. Accumulation, so different rates coming in and out. Position, velocity, acceleration, of course, is a common application. And definitely look for your intermediate value theorem and mean value theorem to be applied here. Remember, you do not know what happens in between the values of the table. You cannot assume that. Make sure you show your work, even if it's just as simple as you're finding the slope. Show the quotient, because this is how you get 1 point for showing the work. If you are doing a Riemann sums, like you're doing a left Riemann sums, and you use the values, like you do, the change in x, of course, and then you do the values of f of 0 plus f of 1, etc. When you do this setup, though, do not write it, sorry, my etc. is not working very well. Do not write it as f of 3. Actually pull the values from the table. So when you show your work then, actually show this number. What is f of 0? What is this number? They want to see that in your work, okay? And last of all, if you are using a theorem, we notice in the directions for the AP exam, they want to see that you stated the conditions. So generally for intermediate value theorem, the function has to be continuous. For mean value theorem, continuous and differentiable. Okay, so you need to be able to do your Riemann sums. You need to know your trapezoid rule. That's a common ask question. Ooh, do you know the difference between, we've reviewed this a few times, finding the average value and then the average rate of change? Again, as I said earlier, mean value theorem, IVT. Use your unit analysis to make sure you're getting the correct response, and give your answer in context of the situation. Whatever the units are, answer back in units. Okay, here's our first example. Now notice you're given quite a bit of information. You've got two functions going on here, and both f and g are differentiable. So that means they're also continuous, so I can use my theorems on this. G is strictly increasing, so we do know that these values then will all be positive, okay? And then we're told a third function, that h of x is f of g of x minus 6. Now answer A through D, show all work in pencil, answer each part, don't give up, and then let's talk about the rubric. Okay, this one was a tough one, wasn't it? Now grade yourself ruthlessly on this. So first of all, you were asked to find, could there be a value r between 1 and 3 such that h of r equals -5? Ooh, that screams intermediate value. You're guaranteeing an existing value. So you needed to find the value of h of 1. So you plugged it into the function given, and you should have gotten 3. And then you've found h of 3, which is -7. So that's 1 point for finding both values correct. And then by the intermediate value theorem, we can guarantee that 5 will exist, -5, I'm sorry, because -5 is between the values at h of 1 and h of 3. Now you did have to say h is continuous, and you did have to say by the IVT. You need both statements to get the point. Now part B is the mean value theorem, because you're asked for the derivative of h. So you did have to find that derivative. Well, because it's a table, then we use the average rate of change. And luckily they chose the same values in A. So h of 3 is 3, h of 1, h of 1 is 3, h of 3 is -7. So we found that that rate of change is -5. So we can guarantee that h prime will be equal to -5 by the mean value theorem. So you did have to say the conditions, it's continuous and differentiable. You did have to say which theorem you used, and there will exist a value c between 1 and 3 such that h prime c is equal to -5. So 2 points, one for showing, finding the slope, and conclusion using MVT. Make sure you stated your condition. C. Now C, you are asked to find, you're given the integral. So you need to apply the fundamental theorem, knowing that the integral, the derivative of w prime, will be the integrand, which is f of t, evaluated at g of x. Well, then you also know you have to always multiply by the derivative of that limit. So you had to find f at g of 3, and then times the derivative of g of 3. Fundamental theorem, baby. So doing that, you get -2. now the last one. You love it, don't you? It's your inverse derivative. Now remember, whenever I see these questions, my first thing to do is to set up my two tables. I have g of x and I have g of inverse x. What fact am I given? I'm given that the x value for g of inverse is 2. So I look at the table. I look to see when is the y of g 2, because that's what an inverse is, and I notice the y value of g of x is 2 when x is 1. So that means the point is 2, 1. So then I look to see, okay, now what is the derivative of g at 1? And so we see the derivative at g is at 1 is 5. So we know the inverse derivative is always the reciprocal of that derivative. Okay, g of inverse derivative, however you write this, at 1 is going to be 1/5. And now we have our slope and we have our point. So write the slope tangent. Whew, that was a pretty brutal one. Now, I got to tell you something. You're going to be more impressed with your score once I tell you this fact. This is one of the lowest historically FRQs. The average score in this was a 0.96. Yes, 0.96. So how did you do? What was your score? Did you learn something about mean value theorem, intermediate value theorem? Did you review finding the derivative of an inverse? Super important on this. Okay, let's do our next one. I promise you it's not as hard. Okay, so then this again is a no calculator question. Notice kind of a similar setup in that you're given f and g, but this time we're not given a third function that relates to f and g. So now you have to find these three solutions, much more straightforward. Go ahead, nail this one. You got it. Show all your work in pencil. Okay, let's go over the answers to this one. So for this problem then, the first question you're asked for f of g of x. Phew, that's a relief compared to the last. So you did k at 3, and then you did the derivative of k at 3, and so you got the slope, you got the point, and you wrote the tangent line. Of course, it's fine if you wrote y minus 4 equals 10 times x minus 3. Okay, part B now, you're asked to do the quotient rule. So low d high minus high d low all over the square of what's below. So again, you get 2 points for the expression. That's this, doing the setup correctly. And then 1 point for the answer of -3/2. And last of all, you're doing a little fundamental theorem here. You're given 1/3 of the second derivative of 2x. Well, we don't know the second derivative, but we do know the first derivative. So we know that when you take the integral of a rate of change, it is its antiderivative evaluated at those limits. So it's going to be the antiderivative, and it's at 2x. Sorry, there's just 2x. Lo siento. So it would be the antiderivative f prime at 2x, and then we always know we have to divide by 2. And we're going to evaluate it from 3 to 1. So now you use the table to find those values. And so if you did the antiderivative correctly, you get 2 points, and then 1 point for the answer. So hopefully this score was much better for you. This was taken from one of our recent FRQs, and so recent years, I mean. So what was your score on this second FRQ? And what weaknesses or mistakes did you make in this? Notice I asked different questions in this one. There was no theorem questions on this, but theorems are commonly asked when given tables.